Every conversation about building muscle after 60 begins and ends in the same place. Eat more protein, more chicken breast, more eggs, more whey protein shakes. And I want to be clear that this advice is not wrong. Protein is essential, and I will never tell you otherwise. But there is a conversation that almost never happens alongside that advice, and its absence is the reason so many adults over 60 are doing everything right on paper and still watching their muscle disappear year after year. You can consume adequate protein every single day and still lose muscle if the biological machinery inside your muscle cells that converts dietary protein into actual muscle tissue is damaged, suppressed, or operating at a fraction of its intended capacity. And in the majority of adults past 60, that machinery is compromised in multiple ways simultaneously. I am Dr. James Mitchell, and today I want to tell you about 10 fruits that address that compromised machinery directly, not through protein, through compounds that no animal food contains, compounds that unlock the muscle-building pathways that protein alone cannot open, that reduce the inflammation, preventing your cells from responding to the growth signal, that restore the mitochondrial function your cells need to power protein synthesis, that improve the digestion and absorption of the amino acids you are already consuming, and that address the hormonal and neurological deterioration that aging imposes on the entire system. We are counting down from number 10 to number 1, with each fruit more clinically significant than the one before it. By the time we reach number 1, you will understand the complete picture of why muscle building after 60 fails when it does, and precisely what to do about it at the nutritional level. Number 10 is watermelon, and I want to address the immediate instinct to dismiss it as a summer snack with little therapeutic relevance, because that instinct is incorrect. Watermelon is the most concentrated natural food source of an amino acid called L-citrulline, and L-citrulline has a specific and well-documented effect on the vascular system that is directly relevant to muscle building in older adults. When you consume citrulline from watermelon, it is absorbed into the bloodstream and converted by the kidneys into L-arginine, which is then used by the endothelial cells lining your blood vessels to produce nitric oxide. Nitric oxide causes the smooth muscle in blood vessel walls to relax, producing vasodilation and increasing blood flow through the vessels. For muscle building, this increased blood flow is not a minor benefit. It is a fundamental prerequisite. Every gram of protein you eat must be broken down into amino acids, absorbed through the intestinal wall, transported through the bloodstream, and delivered to the muscle fiber membranes before it can be used for tissue repair and growth. If the blood vessels supplying your muscles have lost elasticity and produce insufficient nitric oxide, which is precisely what happens progressively after 60, that delivery system is compromised. The amino acids from your meals circulate in the bloodstream, but arrive at the muscles slowly and in reduced quantities. A study published in the British Journal of Nutrition found that watermelon juice supplementation significantly improved post-exercise muscle recovery and reduced soreness, attributing the effect to enhanced blood flow to working muscles, improved amino acid delivery for repair, and accelerated clearance of ammonia and lactate that drive fatigue. Citrulline also plays a direct role in the urea cycle, the biochemical pathway that converts ammonia, a toxic byproduct of amino acid metabolism during exercise, into harmless urea for renal excretion. Elevated ammonia directly inhibits the mTOR pathway, the master signaling complex that drives muscle protein synthesis. By accelerating ammonia clearance, watermelon citrulline removes an active suppressor of muscle growth that most people have never considered. 2 cups of fresh watermelon consumed before or after physical activity provides approximately 250 milligrams of citrulline. The rind contains even higher concentrations than the flesh and can be incorporated into a smoothie for a substantially larger dose. Number 9 is tart cherry. Tart cherries occupy this position because they are the most thoroughly studied natural anti-inflammatory fruit in the context of muscle health, and chronic low-grade inflammation is one of the 2 or 3 most significant drivers of age-related muscle loss that exists. After 60, the inflammatory system shifts into a state of persistent low-level activation. Inflammatory cytokines, including interleukin-6 and tumor necrosis factor alpha, remain chronically elevated in the bloodstream. These molecules produce two specific and devastating effects on muscle tissue. They suppress the mTOR pathway, reducing the sensitivity of your muscle cells to the leucine signal that triggers protein synthesis. And they activate a demolition pathway that upregulates the expression of genes called atrogenies, which produce the enzymes responsible for dismantling existing muscle protein through the ubiquitin proteasome system. You are not simply building less muscle after 60. Your body is actively breaking down what you have built. Tart cherry anthocyanins, specifically cyanidin-based compounds, address both of these problems. They inhibit the nuclear factor kappa B signaling cascade that drives inflammatory cytokine production, and they reduce the activity of cyclooxygenase enzymes that generate inflammatory prostaglandins. A study published in the Journal of the International Society of Sports Nutrition found that tart cherry supplementation reduced muscle damage markers by up to 50% following intense exercise, with creatine kinase levels, a direct measure of muscle fiber breakdown, substantially lower in the tart cherry group than in placebo. But the benefit for adults over 60 extends beyond exercise recovery. By chronically reducing baseline inflammatory signaling, tart cherries allow the mTOR pathway to become more responsive to leucine, the amino acid that triggers protein synthesis. They also suppress the forkhead box O family of proteins that issue the demolition order to the atrogene machinery. This dual action, improving growth pathway sensitivity while simultaneously reducing catabolic gene expression, is what distinguishes tart cherries from most other anti-inflammatory interventions that only address one side of the equation. 1 tablespoon of tart cherry juice concentrate daily, or 1 cup of frozen tart cherries provides a clinically relevant anthocyanin dose. Tart cherries also contain natural melatonin, which supports deeper sleep architecture and the nocturnal growth hormone pulse that drives overnight muscle repair. Number 8 is kiwi fruit, and it is here for a reason that has nothing to do with antioxidant capacity or anti-inflammatory activity. Kiwi addresses a problem that is almost never discussed in the context of muscle building after 60, but that undermines every other nutritional intervention you might be implementing. The problem is protein digestion. After 60, gastric acid secretion declines, pancreatic enzyme output decreases, and intestinal absorptive capacity becomes less efficient. The practical consequence is that a meaningful portion of the protein you consume is never fully hydrolyzed into the individual amino acids your muscles require. It travels through the gastrointestinal tract partially digested, and the amino acids it contains never enter the bloodstream in usable form. No matter how well you have structured your protein intake, if the digestion and absorption step is failing, the downstream benefit is diminished before it begins. Kiwi fruit contains a unique proteolytic enzyme called actinidin that dramatically improves protein digestion. Unlike many digestive enzymes that function optimally only within a narrow pH range, actinidin retains activity across the varied pH environment of the gastrointestinal tract, from the acidic stomach through the more alkaline small intestine. A study published in Advances in Food and Nutrition Research demonstrated that adding kiwi to a protein meal significantly increased the rate and completeness of protein hydrolysis, resulting in more amino acids being released from the food, more being absorbed across the intestinal wall, and more reaching the bloodstream where they are available for muscle protein synthesis. Kiwi also provides more than 100% of the daily vitamin C requirement in 2 fruits. Vitamin C is a required cofactor for the enzymes that produce collagen, the structural protein-forming tendons, fascia, and the intramuscular connective tissue framework. Research from the Australian Institute of Sport, published in the American Journal of Clinical Nutrition, showed that consuming vitamin C 60 minutes before exercise approximately doubled the rate of collagen synthesis in tendon tissue. Stronger tendons allow progressive loading over time, and progressive loading is the fundamental mechanical stimulus for muscle growth. Number 7 is banana. Almost everyone knows that bananas are nutritionally relevant. Almost no one knows the specific mechanisms through which they support muscle building at the cellular level after 60. Bananas provide approximately 420 milligrams of potassium per medium fruit, and potassium's role in muscle physiology goes considerably deeper than cramp prevention. At the cellular level, every muscle fiber contraction requires a precise sodium-potassium ion exchange across the cell membrane. Sodium influx triggers the contraction. Potassium efflux resets the cell for the next contraction. This exchange depletes potassium stores during physical activity, and chronic potassium insufficiency reduces contractile force, accelerates fatigue, and diminishes the mechanical stimulus that physical activity provides to the muscle growth pathway. At a systemic level, potassium functions as a buffering agent against the mild metabolic acidosis that becomes increasingly common after 60 as kidney function declines and dietary patterns shift. This chronic mild acidity promotes muscle protein catabolism and inhibits mTOR pathway activity. Higher potassium intake counteracts this acidic shift, reducing acid-driven muscle breakdown and creating a more favorable biochemical environment for protein synthesis. A study in the American Journal of Clinical Nutrition found that higher potassium intake was independently associated with greater lean muscle mass in older adults after controlling for protein intake and physical activity levels. Bananas also provide rapidly digesting carbohydrates that stimulate a meaningful insulin response, and this is clinically important. The mTOR pathway, the master regulator of muscle protein synthesis, has two activation requirements. Leucine from dietary protein provides one signal. Insulin provides the second. Without adequate insulin, even a strong leucine stimulus produces only partial mTOR activation. Consuming a banana alongside or immediately following a protein meal provides the insulin co-signal that allows the pathway to open completely, making every gram of protein you consume more effective at producing muscle tissue. Number 6 is avocado. Avocado appears on a muscle list for a reason that will surprise most people. It contains a unique fatty acid compound called avocatin B that has been shown to improve insulin sensitivity, specifically within skeletal muscle tissue. After 60, muscle cells develop progressive insulin resistance. This is not simply a blood sugar problem. Insulin resistance in skeletal muscle directly impairs mTOR pathway activation because insulin is one of the two signals required to fully open the protein synthesis switch. When your muscle cells cannot respond properly to insulin, the growth pathway remains partially closed regardless of how much leucine you consume from dietary protein. Avocatin B works by improving the efficiency with which muscle cell mitochondria oxidize fatty acids for fuel. When fat oxidation is impaired, toxic lipid intermediates including ceramides and diacylglycerols accumulate within the cell and are the primary molecular cause of insulin receptor desensitization. By reducing their accumulation, avocatin B restores insulin signaling at the muscle cell level, allowing the mTOR pathway to respond fully to both leucine and insulin simultaneously. Avocado is also the most concentrated, commonly consumed fruit source of potassium at approximately 975 milligrams per fruit, and it provides glutathione, the primary intracellular antioxidant that protects the amino acid transporter proteins embedded in the muscle cell membrane. Research published in the American Journal of Physiology found that reduced glutathione levels in skeletal muscle directly correlated with impaired leucine uptake. When glutathione was restored, amino acid transport improved, and the protein synthesis response to feeding was meaningfully recovered. You can consume all the protein you need, but if the transporter proteins on your muscle cell membranes are oxidatively damaged, the amino acids cannot cross into the cell where synthesis occurs. Number 5 is pomegranate. We have reached the top half of this list, and pomegranate occupies this position because it triggers a cellular renewal process that nothing else in the natural food supply can replicate with the same evidence base. When pomegranate is consumed, the L-tannins it contains are broken down by gut bacteria into a molecule called urolithin A. Urolithin A activates mitophagy, the selective identification and removal of damaged mitochondria from within the muscle cell. After 60, muscle cells accumulate dysfunctional mitochondria that leak oxidative byproducts and generate cellular energy inefficiently. These are not simply inactive organelles. They are actively damaging the cells that contain them, poisoning the signaling environment that protein synthesis depends on, and consuming resources that should be available for muscle repair. Urolithin A clears these damaged mitochondria systematically and signals the cell to produce fresh, functional replacements. A clinical trial published in Nature Medicine found that urolithin A supplementation improved mitochondrial function and muscle endurance in older adults, to a degree the researchers described as comparable to the effects of regular endurance exercise. A subsequent study published in Nature Aging found that urolithin A also rejuvenated satellite cells, the muscle stem cells responsible for repair and regeneration, restoring their capacity to divide and differentiate into functional muscle fibers rather than converting into fat or connective tissue. The consistency and quality of your gut microbiome influences how efficiently you convert pomegranate L-tannins into urolithin A, which is one of the reasons why the complete fruit protocol described today is more effective than any single fruit alone. The dietary fiber from the other fruits on this list feeds the bacterial populations responsible for that conversion, making the pomegranate benefit progressively stronger over weeks of consistent consumption. 1 cup of pomegranate juice or pomegranate arils daily provides the L-tannin substrate your gut microbiome needs. Number 4 is papaya. Papaya is the most underappreciated fruit on this list, and the compound responsible for its position here is one that receives almost no attention in mainstream nutrition conversations, despite compelling clinical evidence. That compound is beta-cryptoxanthin. Unlike most carotenoids, whose benefits to muscle are general and indirect, beta-cryptoxanthin has been shown in epidemiological and mechanistic research to have a specific protective relationship with skeletal muscle tissue. A study published in the British Journal of Nutrition found that higher circulating beta-cryptoxanthin levels were independently associated with greater muscle mass and strength in older adults, with an association stronger than for any other individual carotenoid measured, including beta-carotene, lycopene, and lutein. The proposed mechanism involves beta-cryptoxanthin's activation of a nuclear receptor that upregulates the expression of genes governing mitochondrial function and intracellular antioxidant defense, specifically within skeletal muscle. Beta-cryptoxanthin also directly inhibits the nuclear factor kappa B pathway in muscle tissue and suppresses atrogene expression, giving it a direct anti-catabolic effect independent of its antioxidant activity. Papaya additionally contains papain, a digestive enzyme with proteolytic activity complementary to the actinidin in kiwi, further improving amino acid absorption from protein meals. And it provides substantial vitamin C, lycopene for endothelial function and nitric oxide support, and folate for the methylation cycle that contributes to creatine biosynthesis. 1 to 2 cups of fresh or frozen papaya daily provides a clinically meaningful beta-cryptoxanthin dose alongside these complementary benefits. Number 3 is goji berry. Goji berries contain 2 categories of compounds found in no other commonly consumed fruit that make them irreplaceable in a muscle-building nutrition protocol for adults over 60. The first is Lycium barbarum polysaccharides, complex glycoprotein molecules that modulate the inflammatory immune response in a way that is fundamentally different from conventional anti-inflammatory compounds. Rather than broadly suppressing immune activity, these polysaccharides selectively reduce the overactive inflammatory cytokine production driving muscle catabolism while simultaneously supporting the immune functions that protect against infection. A study published in the Journal of Ethnopharmacology demonstrated that Lycium barbarum polysaccharides significantly reduced circulating interleukin-6 and tumor necrosis factor alpha, the two primary inflammatory molecules driving age-related muscle wasting, without compromising natural killer cell activity or T-cell function. This selective modulation is clinically ideal because pharmaceutical anti-inflammatory approaches that reduce muscle-damaging inflammation also weaken immune defenses. Goji berries achieve the anti-catabolic effect without that trade-off. The second unique compound is betaine, also known as trimethylglycine, which supports creatine biosynthesis through the methylation cycle. After 60, endogenous creatine production declines, and lower intramuscular creatine reduces the explosive contractile power your muscles can generate. Less powerful contractions mean a weaker mechanical growth stimulus from physical activity. A study in the Journal of the International Society of Sports Nutrition found that betaine supplementation increased lean body mass and muscle power output through enhanced creatine synthesis and improved cellular hydration. Research published in Rejuvenation Research additionally found that goji berry supplementation increased serum growth hormone levels in older adults while improving sleep quality. Growth hormone is the primary hormonal driver of overnight muscle repair, and its decline after 60 is one of the most significant contributors to sarcopenia. 1 to 2 ounces of dried goji berries daily or a quarter cup incorporated into a smoothie provides the polysaccharides, betaine, complete amino acid profile, and growth hormone supporting compounds that make goji berries this powerful. Number 2 is blueberry. Blueberries are this high on the list not because of their general antioxidant reputation, but because of one specific compound called pterostilbene and one specific biological function that addresses a dimension of muscle loss that almost no one discusses. Pterostilbene is structurally similar to resveratrol, but is absorbed into the bloodstream 4 times more efficiently. Once circulating, pterostilbene activates sirtuin-1, a protein that functions as a master regulator of mitochondrial renewal in skeletal muscle. When sirtuin-1 is activated, it initiates mitochondrial biogenesis, the creation of new, healthy mitochondria to replace the damaged ones that urolithin A from pomegranate has been clearing. These two fruits work in sequence. Pomegranate removes the damaged mitochondria. Blueberry signals the cell to build fresh replacements. Together, they constitute a complete mitochondrial renewal program. Blueberry anthocyanins also stimulate nitric oxide production in blood vessel endothelial cells, complementing the citrulline-mediated vasodilation from watermelon and increasing amino acid delivery to muscle tissue through a second independent vascular mechanism. But the reason blueberries occupy number 2 is a function that neither of these mechanisms addresses. Blueberry compounds protect the neuromuscular junction, the anatomical connection point between motor nerve terminals and muscle fiber membranes, through which every voluntary muscle contraction is initiated. After 60, these junctions deteriorate progressively. The nerve terminals retract, acetylcholine release becomes unreliable, and muscle fibers that lose their neural connection cannot be voluntarily activated regardless of their physical condition. Muscle without reliable neural input does not respond to exercise, does not hypertrophy, and eventually atrophies despite whatever nutritional support surrounds it. Research published in the Journals of Gerontology found that blueberry supplementation improved neuromuscular function as measured by grip strength, balance, and walking speed in aged subjects. The mechanism involves protection of the mitochondria within the nerve terminals that power acetylcholine synthesis and release, and reduction of the oxidative and inflammatory damage at the junction site that drives the structural deterioration. 1 to 2 cups of frozen wild blueberries daily. Wild varieties contain approximately double the anthocyanin concentration of cultivated options. Frozen retains all bioactive compounds and is substantially more economical than fresh. And number 1 is the orange. I fully anticipate that this will be the most surprising conclusion on this list, and I want to explain precisely why it is correct before the surprise becomes skepticism. Oranges do not contain a single exotic molecule that generates research headlines. What they contain is hesperidin, a flavonone found almost exclusively in citrus fruits at highest concentrations in oranges and tangerines. And hesperidin has a specific, well-documented effect on skeletal muscle that addresses the single most intractable obstacle to muscle building after 60 that no other fruit on this list targets directly: That obstacle is myostatin. Myostatin is a protein produced by muscle cells that functions as a brake on muscle growth. In younger adults, it serves the appropriate physiological function of preventing disproportionate muscle hypertrophy. After 60, myostatin expression increases and the brake becomes too powerful. The muscle cannot grow even when the growth signals are present and the raw materials are available. Research published in the journal Nutrients demonstrated that hesperidin reduced myostatin expression in skeletal muscle tissue while simultaneously increasing the expression of growth-promoting factors. The net effect was a measurable shift in the intracellular balance from catabolism toward anabolism. This myostatin suppression represents the only direct pharmacological level growth pathway intervention in this entire list. Hesperidin also activates the AMPK pathway in skeletal muscle, the cellular energy sensor that coordinates mitochondrial biogenesis, clears the toxic lipid intermediates causing insulin resistance, and primes the cell for subsequent growth signaling through mTOR. It addresses insulin resistance through a complementary mechanism to avocado B, meaning the two fruits provide independent and additive improvements in the muscle cell's ability to respond to the insulin co-signal for protein synthesis. Oranges also provide 70 milligrams of vitamin C per medium fruit, supporting collagen synthesis in tendons and intramuscular connective tissue. They contain folate for the methylation cycle, potassium for acid-base buffering, and nobiletin, a polymethoxylated flavone found in the peel and pith that activates sirtuin-1 through a different molecular entry point than pterostilbene from blueberries, providing complementary rather than redundant mitochondrial renewal signaling. And here's the practical argument that seals the top position. Oranges are available in every grocery store in every region throughout the entire year at the lowest cost of any fruit on this list. 2 to 3 oranges daily is a sustainable, affordable, year-round habit. Eat them whole whenever possible to preserve the hesperidin concentration in the white pith. If juicing, retain the pulp. The humble orange, applied consistently, addresses myostatin, mitochondrial function, insulin sensitivity, collagen infrastructure, and acid-base balance simultaneously. No other fruit on this list does all of those things in a single package at that price point and availability. Let me close by describing what happens in your body when all 10 of these fruits are rotating consistently through your weekly diet. The inflammatory suppression blocking your mTOR pathway is being addressed by tart cherry anthocyanins, goji berry polysaccharides, papaya beta-cryptoxanthin, and blueberry pterostilbene through 4 independent molecular mechanisms. The insulin resistance weakening your growth signal is being reversed by avocado B from avocado and hesperidin from oranges. The damaged mitochondria poisoning your muscle cells are being cleared by urolithin A from pomegranate and replaced by fresh mitochondria stimulated by blueberry, pterostilbene, and orange nobiletin. The protein digestion failure, wasting the amino acids from your meals, is being corrected by actinidin from kiwi and papain from papaya. The blood flow restriction limiting nutrient delivery to your muscles is being reversed by citrulline from watermelon and anthocyanins from blueberries. The acid-base imbalance promoting muscle catabolism is being buffered by potassium from bananas, avocados, and oranges. The myostatin brake preventing new growth is being released by hesperidin from oranges. The growth hormone decline reducing overnight repair is being partially addressed by goji berry polysaccharides. The neuromuscular junctions connecting your nerves to your muscle fibers are being protected by blueberry compounds. And the creatine deficit reducing explosive contractile power is being corrected by betaine from goji berries. Every significant pathway through which sarcopenia operates is being addressed by at least one fruit in this protocol, and usually by 2 or 3 working through independent molecular targets. You do not need to consume all 10 fruits simultaneously every day. You need to rotate through them consistently across each week so that every pathway receives its supporting input regularly. Bananas, kiwis, and oranges are simple enough to consume daily. Blueberries and tart cherries can alternate. Avocado accompanies protein meals. Pomegranate and goji berries serve as consistent additions. Watermelon and papaya fill the remainder of the rotation. These fruits do not replace dietary protein. They do not replace physical activity. They make both work the way they are supposed to work in a body past 60. Protein is the raw material. Exercise is the stimulus. These 10 fruits are the biological environment, without which neither protein nor exercise can produce the results they are capable of producing. Here is my challenge to you. Choose 3 fruits from this list that you do not currently consume regularly and add them to this week's shopping. Begin there. Build the rotation progressively. Come back to this video in 4 weeks and leave me a comment. Tell me your age, where you are watching from, and what you have noticed. Your honest account of that experience is the evidence that someone else in this community needs to move from understanding this information intellectually to applying it consistently in their own life. If this video has given you something useful today, please share it with someone you care about and subscribe to this channel for weekly medically grounded guidance made specifically for adults over 60. I will see you in the next one.